Hello, Michael here. This is a very short video about how I think Pythagoras discovered the proof of the theorem that bears his name. First of all, Pythagoras lived about 2,500 years ago. He wasn't the man who discovered the theorem, it had been known for about 2,500 years before that. He was the person who discovered the mathematical proof of it. If you want to know more about Pythagoras the man, Wikipedia is a good place to start. Well, first of all, the theorem is about right-angled triangles, like this one. It states that the square on the hypotenuse is equal to the sum of the squares on the other two sides. That means the areas of the squares. So, here are the squares on the shorter sides of the triangle. They're easy enough to construct. It will make life a little easier if we label them. The standard way is A and B for the short sides and C for the hypotenuse. Now this is how I think he constructed the square on the hypotenuse. He knew that the two smaller angles add up to a right angle, and so he knew that he could start with one triangle here and add another and another and another and finish up with this perfect square on the hypotenuse. Notice that this square of side C is made up of 4 triangles, and don't forget that little square in the middle. To make things easier, we'll add colour and number the triangles. Now, let's zoom in and look in a little closer detail. Now, we can translate triangle 1 down and to the right, like this. And we can also translate triangle 2 down and to the left, like this. Now this L shape has exactly the same area as the square, that's C squared. It's exactly the same triangles and the small purple square, it's just that we've rearranged them slightly. Now let's zoom out again. Watch this. First of all, we have the rearranged square, and we can completely cover it with the light brown and the dark brown squares. And that is Pythagoras' theorem. Let's look at it again and explain it. So, the coloured area, the rearranged square on the hypotenuse, that's C squared, is equal to the dark brown square, that's A squared, plus the light brown square, that's B squared. So we've proven that C squared equals A squared plus B squared. And we've done it in exactly the same way as I believe that Pythagoras himself did it. You might want to convince yourself of this. Have a look at my website and you can download a diagram in PDF format, and then you can investigate it at your leisure. Now, this isn't the only proof. If you do a Google search on Pythagoras proof, you'll find literally hundreds of them. For those who enjoy algebra, this same proof can also be done algebraically, and it's very simple. All you need to know is the formulas for area, and you need to know how to expand brackets. Now, the square on the hypotenuse is made up of the purple square and 4 identical triangles. The side of the square is A minus B. Please convince yourself of this before we go any further. Look at the diagram until you're absolutely sure that the side of the square is the same as the difference between the two sides of the triangles, the long side minus the short side. Now, the triangles have a base of A and a height of B. So, the area of the square on the hypotenuse is the area of the small purple square, that's A minus B squared, plus 4 of the triangles, that's 4 times a half AB. So, the area of the square is then A squared plus B squared minus 2AB and the area of the four triangles is 2AB. So we've got 2AB and minus 2AB. They cancel out, they add up to 0. So what we're left with is c squared equals a squared plus b squared, which is exactly the result that we were looking for. So there you are, two proofs of Pythagoras' theorem for the price of one very simple diagram.